So this is Adrian Tymes. He is with CubeCab, and he is going to talk about affordable launch for small satellites.
CubeSat specifically. And Eugene, you were going to drive the slide deck?
I can drive the slide deck, so let me do that.
Okay. I'll wait.
Nope, that's not it. Let me find it here. There you are. All right. So is that showing?
Yep. It's showing what's showing here. And anyone in the audience confirm?
Yeah, I won't be able to see it. So, Craig, can you?
I can see it.
I can see it.
Okay.
Yes, I see it.
Okay, good. Thank you. Okay, so I'm Adrian Tymes, founder and CEO of CubeCab. We are yet another launch services company, but we are focusing on what I call microlaunch. We specifically are developing vehicles to launch CubeSats to LEO. If you've never heard the term, it's basically 5 kilogram or smaller, about this big satellites. There's a very good reason for that. Anyway, next slide. So yeah, we are a small business for small launch. The differentiation is SpaceX, ULA, those guys. They're doing the large launch model. They can launch the large payloads. They can launch small payloads on the container ship model. But that's not everything. As I put it, sometimes if you got a small payload and you want to get to space, they're sort of the equivalent of trucks and buses. It's great if you can go where they want to go, or where they go, when they want to go, and you're compatible with all the other satellites on the ride. But if you just want to put up your own satellite to a specific orbit on your schedule, you're SOL. It's an unmet need that we're trying to serve. So as it shows, everybody else is a container ship. We're more like FedEx. Next slide.
Sorry, give me a sec. Okay.
So yeah, the micro launch is a very underserved model. I'm not seeing too many rockets out there that'll launch even less than 100 kilograms, and certainly none that'll launch for less than $1 million for the entire rocket. If you can't ride share, you can't launch under today's market. Typically, a CubeSat or anything less than 100 kilograms, and even larger ones, it's 12 to 24 months to get a launch going anywhere. So if you want to launch something quickly, like say within a given academic year, or you're at a Space Force and you need tactically responsive launch where something happens on orbit, you can't wait 2 years to launch something, you don't have any options right now. That's what we're trying to fix. So what we're making is what we call the Cab 3A and the Cab 3B, depending on which details. But it's a small rocket. It's an air launch, also known as air-to-space missile. It's a plane, rocket, strap on, up in the atmosphere, shoot up into space. Standard airstrike mission, except you're targeting orbit instead of the ground. We're going for a standardized price, only $250,000 to launch the Cab 3A. Cab 3B is a little more expensive, but about the same. The competitors sometimes quote variable rates. SpaceX's rate changes all the time, but even for a CubeSat, they're still above what we're doing. It may have heard SpaceX is underpricing the rest of the industry. They're not underpricing us for what we do. And we de-risk the mission because we're not piling a whole bunch of payloads on a single rocket that might explode. We're piling one payload on something that might explode and then launching a whole bunch of them. So if we have an explosion, it takes out 5 kilograms rather than several tons of satellites. Next slide.
Okay.
Slide 4, please. Thank you. So our intended path, once we can get development funding, is roughly 2 years to finish building our rocket. We have the basic plans. We worked out on math. We need funding and other parts to start bending metal. It's very much a safety first development path. First, you prove safety to the plane and the pilot. And only after that do you put rocket fuel anywhere on, and then you do suborbital launches, and then you do orbital launches. We've got quite a few customers who say they are willing to give us a whole bunch of orders once we get to orbital launch, but not a penny until then. So we're trying to cross that valley of death. That's why the Gantt chart has the dev and ops in different colors. Once we hit operations, it's a straight up scaling model. Start with 30 launches per year. Second year, 100 launches. Keep note, as even SpaceX is struggling to reach 100 launches per year. Mainly because they don't have the customers. Even with their captive Starlink orders, they just don't have the customers to justify 100 launches per year. We do. There's been over 100 CubeSats launched every year for the past several. And then once we can scale up, we might scale up further, or there are certain next generation technologies we can do that might be able to let's just say advance it to under $100 per kilogram. I've discussed some of these with Eugene. Next slide. So for those who don't know what stone soup is, it's an old story of someone comes to a village with a stone and a cauldron. People ask, well, what are you making? I'm making some delicious stone soup, but it would just go so much better if I had this ingredient. It would so much better if I had that ingredient. People pitch in the ingredient in exchange for part of the soup, and then in the end, it's got some soup. So we've got some of the components, not all of them. Partnerships we're looking for are high explosive manufacturers, make solid rocket motors. We need help talking to some of them because a lot of them keep saying, oh, well, any rocket program, we're only going to get 5 rockets worth. I just said we're going like 30 in our first year of operations and then hundreds per year after that. So we need to convince them that, hey, you need to justify your pricing based on making hundreds, not individuals and one-offs. Then we're looking for airframes. The CABS 3A design goes off of the F-104. It's a Vietnam era jet. We got some private sources for that. CAB 3B, if anyone's got F-15s or F-35s, and in particular, any willing DoD installations, because the CAB 3B is specifically intended for DoD use. The CAB 3A can guarantee launch next business day. The CAB 3B, the intended model is these rockets are sitting at an air base or carrier or wherever, with pilots trained and with payloads already there, so that in an emergency, you can pop the payload onto the rocket, pop the rocket onto the plane, launch immediately, and DoD has a response within a day, possibly within an hour, depending on the exact circumstances. So if, say, Russia does another destructive ASAT, or some chaser satellite gets unnervingly close to something that some multi-million-dollar asset in space, we can pop this sub-million-dollar response up to clean up the debris, to bodyguard the whatever asset is, block the chaser satellite, be able to do something on orbit, even if it is just with a CubeSat. And then, of course, we need funding. We're looking for roughly $10 million to get from where we are to first successful launch. And like I said, once we get the first successful launch, we should be able to get commercial funding to completely sustain the program after that. Next slide. Yeah, Eugene said to be brief. Did I keep it brief enough?
Sorry, yeah, it was a little bit too brief, but
yeah.
So why don't you talk about what your goals are? I mean, what do you really want to see happen? I mean, that irregardless of the funding, what is the end game for being able to
better space access? Better space access. Better space access. Okay. CubeCab started originally from academic need. I have an academic background myself, and I was talking to a bunch of university space programs, and they were bemoaning it takes 2 years. The tale told me was a typical graduate space experience is one grad student takes 2 years to set up an experiment in space, does the modeling, build a satellite, and so on. And then a second graduate student 2 years later actually runs the experiment. That's no way to do space access. So I was looking for instead, well, what if you could, in theory, guarantee a launch, say, in spring break, and then you place the order back in, say, September or so when the academic year starts. So you could do a single year undergraduate class. Now, I'm from quarter system rather than semester system, so I was thinking fall quarter, you teach the basics. Winter quarter, you build the satellite. Around spring break, you get the launch. And then spring quarter, the students operate the satellite, get the test data, and deorbit it at the end of the academic year. University graduates students every year that have experience in space, that have done something in space. Quite a sellable skill for universities looking to have proof that they are training their graduates to actually participate in the workforce.
So what kind of calculations need to be done, and what's the time frame? I mean, obviously there's a lot of calculations to put things into orbit, but as far as these CubeSats and small sats, I'm kind of thinking all the services do touch and goes. Everybody has to get their flight hours in every month to stay certified. And so would there be the ability to tie what you're doing into when people are doing touch and goes. And I know there's some people from Nav Air and the Air Force on here right now, so they can chime in as well to let me know if that's even viable.
Yeah, so a lot of the calculations have already been done. Keep in mind, we've been doing satellites for how many decades now? There's quite a bit of software support out there. There are programs out there where you can plug in your data and see, okay, what's the likelihood of a collision? What orbital slots are available? NASA, for instance, puts out a debris tracker where updated every several months, where you can just plug it in, see what's the likelihood of a conjunction. That's actually not the main gating factor, at least on the civilian side. And I think it may be slightly on the military side too. It's licensing. To put a civilian satellite up, the FAA needs to approve the launch vehicle, which in our case it will have done in advance. And they've been talking about doing a launch operator's license, which just authorizes the class, so I don't have to review which individual one. But the payload needs to have FCC licensing, and the FCC has kind of stepped up as a de facto private satellite licensing agency because there isn't really a government-wide satellite licensing. They can justify as, oh, well, anything doing radio telemetry needs to get an FCC license, and it does. So they take in a bunch of other factors too. People have been trying to do laser comms, even now the CubeSats have been doing laser comms specifically to get around this, because FCC doesn't license laser comms because lasers don't have interference. I mean, so long as you're not like lasing an airplane cockpit or something,
Right.
but they don't have interference in the way radio does. So, yeah, that licensing can take several months. DoD, as I understand it, can in an emergency rubber stamp stuff, and that's why I say for them we can do next business day. That's the engineering practicalities.
Okay, so Air Force people, Nav Air, whoever's on,
Okay, what
would
are
this
the
be
benefits
viable
of?
hold on. Would this be viable for you guys? I mean, could something like this work into the touch and goes? Andrew, Brian, Jalal?
So speaking from the academic side, AFIT does launch a number of CubeSats, and it did follow Adrian's description of, we were on quarters as well. So there were periods where one student would key things up, and two students later would actually get to launch and benefit from that. So faster space launch for small items would definitely be appreciated within that academic setting, among others, I'm sure.
Yep.
But what about access to the aircraft, though? That's my question, because these are launched from an aircraft. These aren't launched from the ground.
Yeah. We were modeling specifically as similar to an airstrike mission, except again, targeting orbit instead of the ground. So while I am not specifically an expert on military access to aircraft, from what I understand, it should be about within the same parameters.
You mentioned the F-104 starfighter frame as your original design carrier vehicle, and then
Yeah.
you mentioned the F-15, F-35. Those are so the F-15, F-35. I mean, they do carry common components, but access to one of those outside of national emergency is going to be pretty difficult for U.S. for non-military purposes. Are you intending the Cab B to only be sold to U.S. military suppliers, or are they something you would allow to sit on the runway with any allied nation, any private company that has reason to rapidly resupply their CubeSats in space?
So that's two very significantly different questions, and I'll answer both of them. Allied nations, of course, depends on the whims of Department of State licensing, but we have definitely had talks with certain allies, for instance, UK Ministry of Defense, of the possibility of allowing them to run their own Cab 3Bs if the Department of State approves. There's not been any action on that yet, but definitely they say this would be something that would be desirable once we have the Cab 3B actually developed. They don't have any development funding for a U.S. space program. So, as for private companies, if we could get private access to probably like a demilitarized F-15, the Cab 3, we could do the Cab 3B. The Cab 3A is always much more intended for the civilian market because there are demilitarized F-104s. And the F-104 can go higher and faster, so it's less cost. The Cab 3B estimate about 150,000 extra because we need that much more rocket because because the jet can't go as high and as fast. But it does have the extra tactically responsive benefit, so it would mostly be of use to the military, be it foreign or be it U.S. or allied. I mean, obviously, China is
Yeah.
never getting a hold of this thing. Do not. Yeah.
Okay. Actually, there's a couple private companies who I can't blank on the name of that supply aggressor aircraft for the U.S. Air Force for the red flag training and that sort of thing. I was wondering if that would be a private company that you could contract with. And I'm curious if you have any reach out to, I'm trying to think, like the link to another company that has the killer app CubeSat that you guys could partner with to make a more appealing package. Look, they've got this CubeSat that can do the bodyguard mission or the refuel mission or the garbage cleanup mission, and that would need a much more rapid launch cycle than waiting 16 months to get a spot on SpaceX's or United Launch's next big carrier rocket.
So again, two questions, and I'll answer both of them. We have not been specifically in contact with that company, and I will admit that's been part of our problem. Is we've been trying to reach out, and so often when we try to reach out, no response. Emails not answered. Voice or phone call goes to voicemail, never answered. Reach out on LinkedIn. No, it's like the contact info goes to dev null in the IT terms. So if you have contacts to them and would like to introduce us, I would be very appreciative. We'd be very appreciative for that. As to the killer app, that is actually a side business, and actually we've almost gotten more revenue from investigating killer apps through the SBR and certain other research grants than we have from development of the Cab 3A itself. And I didn't want to go into the range of them because if I do, it starts making it sound like we're defocused out of the core mission. But there have been quite a few possible apps that we can do. In fact, you specifically mentioned garbage cleanup. If you look up CubeCab Eats Debris, you'll find the public version. There's a bunch more stuff in private, but we did in public about a potential garbage cleanup satellite specifically focused on the smaller debris. There's a bunch of solutions for debris that's greater than 10 centimeters because that's what can be tracked by publicly emitted ground radar. Not so many for debris that's less than 10 centimeters, even though there's like, I think hundreds or maybe thousands of large debris, and there's millions of smaller debris pieces. The way this works is it is a CubeSat that you deploy it to the known or suspected location of a debris cloud. It uses onboard radar, being much closer to the debris, to find the small pieces, goes to each one, gobbles it up, and processes it into fuel so it can go gobble the other. Basically turning debris, orbital debris, into an in situ resource as for fuel, giving basically indefinite delta V. We can't get any takers on that.
All right, thanks, Jeremy. Was that it?
I think that's the end of all of my 2-for-1 questions.
Okay, yeah.
Fair enough.
If you wouldn't mind sharing those contacts either in the chat or through email, and that's what we do here is make these connections and drive them forward, because that is one of the biggest challenges I identified with innovation is it tends to stagnate way too easily.
Yeah.
All right, so the
And
next question that was in the
is David Siegel's. What are the benefits
so
of small rocket launchers?
Don't read the question. That's not how we do this. So David, I asked Adrian this question just the other day. I think just 2 days ago when we were talking. So go ahead and ask your question.
Sure, bear with me. I would have almost liked him to go ahead and ask the question. I'm having an asthma situation, but
okay, that's fine.
It's okay. It's what are the benefits of small rocket launches of CubeCab versus a kinetic launch solution such as spin launch? And by the way, I'm coming from a background knowing very little of launches in general. So
okay, so fair enough. Most people are not rocket scientists. Let it be said. In fact, even I wasn't born a rocket scientist. Anyway, so first off, there is the exact mass category of, are they launching 5 kilograms, 100 kilograms, a ton, or whatever? But let's take that out of the equation because you're just seeing rocket launches versus kinetic. So just apples to apples, let's assume there was a spin launch that did launch just 5 kilograms. So in theory, spin launch might be able to achieve a better access to a specific orbit. Problem is, they are fixed on the ground. So a rocket launch, be it ground launch or be it air launch, it can go to this orbit, it can go to that orbit, it can go to that orbit, whichever. Unless they put in something to allow to rotate their facility, and I've seen it, and it doesn't look like they have. They can go to this orbit and this orbit and this orbit, and if you want to go to there, they can't do you. That's the short and sweet version. Also, they don't entirely eliminate the need for rocketry. So to get to orbit, first you have to get to orbital velocity on this side of your orbit, and then going around, you have to be on orbital velocity on the far side of your orbit. That's part of the reason why there's typically 2 or 3 stages. First 2 is to get up and then get to orbital velocity on the starting side, and then the last stage is usually to circularize your orbit. They actually do have to have rockets to circularize their orbit. So they're basically eliminating stages 1 or 2, but they're not eliminating the last stage of the rocket. They got a hybrid approach. Also, a rocket will apply its thrust over multiple minutes, or at least multiple seconds. With spin launch or any kind of kinetic, you got a very high thrust right at the beginning, which kind of limits the payloads you can put in. No way are you putting a human on that. Now, granted, you're not putting a human in 5 kilograms anyway, but this technology has been used at larger scales to put humans up. But for instance, also like delicate electronics, unless they're rated for high Gs, can't do. Bulk goods they can do, but there's limited demand for bulk goods on orbit right now. Eventually, there might be. They certainly would have their place in a far more developed space launch economy than we have today. Problem is, we are dealing with what we have today. Did that sufficiently answer your question?
Makes total sense. Very fascinating. Thank you for answering.
Sure. And I am trying to keep it to the layman's explanations here. If you want more detail, please let me know, or follow up by email. I can talk your ear off all day. I don't have all day, and there are multiple questions to get through here.
All right, so there have been a couple of people that have chimed in just recently. Major, did you have any questions? We're kind of through the presentation. The presentation was about 15 minutes. So do you have any specific questions, sir? I'm not hearing anything.
I do have backup slides if people want extra material for this and that application. Should we go through them?
Yeah, it wouldn't hurt.
Okay, next slide then. Like I said, I was told to keep the initial presentation quick, but have the backup slides in case people were asking. So yeah, so we are focused on a multi-user segment. Like I said, we were founded thinking of academic. Actually, the military application just shook out of what we were developing. I hadn't even heard the term tactically responsive until a few years after we'd founded, and the Space Force came up with those series of, hey, there would be this military use if we could do rapid launch. And I was just, yeah, so we were just happening to do rapid launch, but if we do this, this, and this, yeah, we could get it down to a single business day. And if we tweak it further, so the CAB 3B was actually born out of, I believe it was a ONR request. Some people over there who I have been informed have since retired, so don't worry about that contact. Asked out of curiosity, well, if we can do a F-104 launch and we're doing all solid rocket, could we do a carrier launch? We took some months to investigate, and the answer was yes. And they specifically said, since you're doing solid fuel, which would be more permissible to store on a carrier than liquid fuel. I'm not aware of the regs, but I took their word for it. And so the answer was yes. And we could do the specific fighter jets that are sometimes stationed on carriers. I'm still not sure what economic sense it would make to launch from a carrier. There may be some classified missions I am unaware of. Fine, you have to use case. I'm here to make your use case happen. Tell me what you need. But yeah, in addition, we're also looking at the academic and small corporate market as well as the government.
So let me interrupt you there for a second. Back to your carrier launch.
Yeah.
Does it matter where you are geographically on the globe
It may.
as to where your satellite ends up?
It may. There are certain orbits that are much easier to access from if you're launching from the equator than if you're launching anywhere further north or south.
Okay.
But these orbits are not commonly accessed. Usually, most satellites are perfectly okay with being launched significantly north or south of the equator. But also, if you're trying to launch something heavy and you just want to in orbit anywhere, that's easier to do from the equator as well. In fact, we've been in talks with Brazil trying to get into the Alcantara Space Center specifically to see if they're willing to host us. And that's, again, yeah, we might be able to host you after you demonstrate orbital launch. Catch-22 there.
Okay. So go ahead, Jeremy, ask your question.
Yeah, I put a note in to jog my memory in case the answer took longer. Have you considered partnering with any of the other companies that are doing the air-launched to space route, like Stratolaunch or Virgin Galactic, or not? Well, obviously not on their space plane, but their same carrier plane. If you could adapt, even, I mean, you could do a multi-launch from one right up on one of those fairly giant super 747s or whatever the hell they made.
So again, that's a 2-in-1 question. I'll answer both of them.
Can't resist.
Hey, no offense taken. It's quite okay. So specific partnering with them, they are targeting different markets, and they don't really have that much of a use for our technology. In fact, those companies, I have made a study of what not to do in my career. This CubeCab is far from my first startup. And for example, I was a shareholder in C-Corp, which was trying to develop their own plane to be the first stage of taking stuff to orbit. And from what I learned of observing that and Virgin Galactic and so on, is that developing your own plane is not the way to go for this kind of thing. That's why we're using existing airframes only, like the F-104, like the F-15 and 35 and so forth. Other people have already paid to develop them. Other people have paid for the FAA certification. We don't have the launch volume to justify even owning a single plane for ourselves full time, let alone developing a plane. And that sometimes gets taken as an affront to their entire approach if it's brought up. So yeah, we don't really have that much way to interact with them. And also their customers, their target market is different from ours. And I'll get to that slide in a bit. As to doing multi-launch, that kind of defeats the entire point of doing the micro launch. Now, in theory, possibly, okay, you have a plane go up and it goes and launches here, and then it diverts and launches over here. There is some room for that, but not really, and the overhead kind of kills the cost efficiency and the cost of using a plane designed for larger launches. I mean, there's a reason we are not citing, say, the B-1 to carry our stuff aloft, or 747s. It's way too big, way too expensive.
Yeah.
Does that answer your question?
Very well, yes, thank you.
Okay. Actually, heck, skip the 2 more slides. Let's bring up the competitor bit since it's been brought up. One more. Okay. Yeah. So a lot of our competition, and by competition I mean the people doing the closest thing that we would substitute for, kind of falls short of what would be called direct competition. Russia and China and so on, they do national pride, large, expensive stuff. They do not launch CubeSats for the most part, and if they do, it's just ancillary. The powers that be in those things may not have even heard of the small parasite rides. India does some of it. I mean, they certainly do launch a whole bunch of CubeSats, but again, they launch a whole bunch to this orbit. And so if you want to go over here, you have to wait until and if they have something going over here. Boeing, Airbus, Lockheed, ULA, and so on. Again, large vehicles. It is possible that they might acquire by merger and acquisition. In fact, back when I was initially doing the research that led to CubeCab, I talked to engineers at Boeing and Lockheed, and they told me specifically the only way they would ever get a capability roughly like what I was talking about was if someone like me were to found a company, make it successful, and then they buy it out once we get to about 100 million revenue. Adjust for inflation over the past 10 years, but that's still historically about when they buy out a company. So, okay, that is certainly one possible path we could take. Virgin Orbit and so on, they got low launch volume. and now I'm talking to stuff below SpaceX, but still above what we're doing. Most of their payloads are 20 to 500 kilograms. Typically, you're talking $1 to $10 million per launch. And again, they are constrained by the number of customers they have at that payload or size. If you take a look at SpaceX, the only reason they've been able to get anywhere near the launch cadence they have is they've got Starlink as an internal captive customer. Take out the Starlink launches, and I don't think I'm not sure they'd even be getting 25 launches a year. There are people who speak of a crowded launch market, like, oh, there's this glut of launch startups. They're referring to the guys doing what I call the mid tier, the 20 to 500. There's not anyone or not even that many doing less than 20, and above 500, you know, all the big guys, or you've heard them probably. And also SpaceX is, you may have heard, undercutting the prices of the mid tier, driving them out of business. We're one of the few that they have not been able to undercut. You go to SpaceX.com, that's right here, even today, or well, last month I looked it up, they might have changed. But every time I looked, if you go to their site, you would say you want to do a 5 kilogram payload. You're quoted something 18 to 24 months out as the first opportunity, and a price that's greater than $250,000. It's almost as if we're the one company that they're allowing to exist. I'll take it. And of course, there's also, oh, well, when you're competing with free launches, like NASA's CubeSat launch initiative, someone else is paying, like say NASA in that case. And so the actual customer is whoever's paying. If you've ever heard of Amazon.com's early strategy, the long tail, where they made the bulk of their stuff on masses of books that didn't sell very many individually. Well, likewise here, a large number of CubeSats that don't have a common orbit. Like, oh, maybe there's a whole bunch of CubeSats going to this orbit. Fine, well, let SpaceX or ISRO do that. There's one or two going over here. We'd be the only option. That's where we make our profit. That's where we focus on our sales and service, in addition to the tactically responsive and the other missions.
So
Adrian, go ahead.
Did you want to touch on anything that you're discussing with Michigan, or no?
We'll see if the Michigan stuff pans out. That is one partnership I'm looking at for access to airframes and a launch range. So yeah, a week or two ago, the Michigan, a large company in Michigan, I'm blanking on their name.
Michigan National Guard.
Thank you.
It's Army and Air National Guard.
There was some, National Air War Space Center or something like that.
Oh yeah, the Joint
and
Domain Warfare Center, something like that. Yeah,
something like. Anyway, those guys were asking about possibly being a launch range, and we are certainly in talks with them as one possible site. Our initial launch site was going to be Kennedy Space Center. We run into a little paperwork snag there, so we are looking for alternative airframes and alternative launch ranges, just whatever comes up. Certainly, they would be able to do emergency launches on behalf of the rest of the DoD, and they and then there's another bit there is, how do I best put this? Okay, so for classified missions, where you have, so currently when you when you launch a satellite, you typically have to deposit the satellite in the launch or operator's facility several months in advance. Now, I was initially looking at this from the problem of biological payloads, or other things that that are built and have to be continuously powered. And there have been some problems over the past few years with such things where power got disrupted, or there was a launch delay and the batteries wore out, and so the mission was literally dead on arrival to orbit, or metaphorically, if it wasn't biological, but the power ran out. Well, it turns out that this is also useful for certain national security stuff, where, say, you have a classified thing, or secret or top secret, whichever, and you have concerns about the security of the contractor's warehouse. Well, so whether you have something that needs special containment because of the contents, or something that needs special containment for security, either way, just have the launch, someone with the payload show up on launch day, that someone will have received prior training from us on how to operate our launch processing machinery. They walk up to the rocket, if necessary. If it's a classified thing, draw a shroud around the area inside a hangar, around the nose cone, process the thing, and the process by shoving the payload into the rocket and into rails and screwing the nose cone on, at which point nobody will have eyes on the payload until either it's in orbit or there's a launch failure and the thing is in little bitty pieces scattered over the Atlantic. It's pretty secure either way. So
Okay, so Andrew, you have a question? You may not have a mic.
okay, should I read or do you want to read it?
Go ahead.
Okay. Is there a payload parallel to where you can take the cab to any vehicle if I have a universal interface? In fact, if I understand the question correctly, yes, there are. Without going into too many details, one thing that has come up now and then is what I've referred to internally as the HackSat, which the best way I've heard it phrased is nobody expects you to have a USB drive in space. So if there is a satellite with exposed electronics, or literally a USB slot, or just you want to get up and like put a squid thing or a squid detector on their electronics, we could launch you if the satellite is in low Earth orbit. We can launch you to an intercept trajectory, get you pretty close, and you'll still have to do the last kilometer intercept. But rather than, oh, you're lurking way months in advance and there's a lot of warning, it's no, they may detect on launch, but that gives typically no more than a couple hours, probably less than an hour launch warning between, okay, they detect the launch, it's coming up to intercept their satellite, and then you got the intercept and you're doing whatever you want to it. Now, granted, that'd probably be more of a wartime thing, and hopefully not something that we would be actually using anytime soon, but the potential's there. I mean, outside of like demonstrations on our own or repair satellite. If you want to demonstrate all the technology for that, it's, oh, you got a disabled satellite in low Earth orbit. Well, rather than launch a multi-million-dollar replacement, $250,000 for the launch, plus maybe $250,000 for the satellite and operations, $500,000, get a repair satellite up, fix this thing on orbit, and there you go. Also, it can launch faster than the multi-million-dollar, multi-ton replacement.
Did that answer your question?
A further a further thing, so that debris removal satellite that turns debris into fuel, it was designed to be able to dock with a processing facility on orbit, like a 3D printer or something, offload part of its fuel tank for use as feedstock, and then go grab more fuel to devour. There are standard universal interfaces that can be employed for that kind of thing. Okay, so backup slides, which one should we do next? You're quite welcome.
Your conversation about docking in orbit has me thinking about rendezvous of multiple CubeSats in orbit to do something like boosting further out into space or boosting to a higher orbit or getting a CubeSat around the moon. Yeah,
Adrian was on that call when we were discussing that.
Why, yes. And yes, you can certainly do that. Like, one design that's been bandied about is a 3 CubeSat one. One is an engine block, that's the main spacecraft. One is just a fuel tank, and one is whatever the customer's payload is that's designed as a regular CubeSat. The engine block, so all three are launched to approximately the same thing, like I was just mentioning with the rendezvous. The engine block has enough onboard fuel and processing capacity to dock with the fuel tank, dock with the payload. And then it's got enough boost to transfer to from low Earth orbit to low lunar orbit, detach the payload, and then return back to low Earth orbit. Ditch the fuel tank into an orbit that will decelerate and re-enter the atmosphere. And since it's just an empty fuel tank at that point, it will burn up. And then the engine block just waits for another fuel tank and another CubeSat to cycle to the moon and back. The engine blocks specifically requires a bit of advanced ion technologies, and that would be one of our partner organizations, but it is possible if anyone had the funding for it. And then that would be just a reusable, okay, transfer up, transfer back, take about a month each way. So we can transfer optimally 6 payloads to low lunar orbit per year. And if you really need more than that, launch another engine block.
Yeah, and it's this, what Adrian does is a perfect technology, perfect solution for this forum, because there are 100 applications for what Adrian does. And that's why we bring these people together to identify these. And now the next step is that if there's any interest in investigating these further, please, I'll be reaching out to everybody that has commented here and talked here, but other people that may not have, please reach out to myself or Adrian, and that's what this is about. We want to know, what are the what ifs, what are the can you, have you ever thought of, maybe, possibly, because that's where the aha moments come in. So I think we're getting a lot of good conversation here. I appreciate that.
Yeah, and actually, if you want something that's extended from that, the docking plus the do something within an academic year, marry those together, and we have a project that's been called LegoSat, which is that you take that launch within an academic year, form it out to a bunch of cooperating teams. It was specifically discussed within the ROTC capacity. For Air Force ROTC and these days Space Force ROTC and anyone else who might be able to justify making a satellite. So you got a team of maybe 3 to 5 cadets who cooperate to make a satellite on the one academic year long, as previously described, except rather than individual operations, you got, say, 20 or 30 or so of these teams. So you're training maybe 100 of these cadets all at once to launch 20 of these satellites. And yeah, 20 launches once a week, a bit of a surge capacity, but we could certainly do that. And we launched them all to roughly the same orbit. And then they are designed to dock to each other into a giant cross, with a little slippage of tolerance for maybe a few of these programs mess up. These are ROTC cadets. Not all of them are going to get it perfect, but assuming most of them do, you then wind up with a rather sizable synthetic aperture device. If each of them has a small sensor and communicator, you basically have, I'm forgetting the name of it, but it's one of these large satellite observing programs, and just transfer it out to use by the rest of the government or by other parts of the DoD. And you've got it all paid for and built from student labor. And you just, okay, you got another large synthetic aperture satellite that can do Earth observation every year as part of just, oh, and by the way, you're training all these cadets. And yeah, all of those pieces would work together. Okay.
So now you're talking about, one of the things that I've worked with in the past is space-based solar power. And when they talk about, in order to make it truly functional, you would need a solar collector that is at least 5 kilometers in diameter. And you're not going to launch that. You're going to have to construct it in space.
So that might be a little beyond the core CubeCab capability, but I certainly have done some tech development towards that end. That gets more towards, my personal favorite is set up some mining and refining capability on the moon and launch solar panels from there. What Cube can do towards that is launch satellites to set up a solar panel recycling. So some government parts are trying to, or some government agencies are trying to push lifespan of a satellite is no more than 5 years unless it's specifically designed to go longer. Lifespan of a solar panel in space is about 15 years. So if you got a design lifespan 5-year satellite, what you could do is have these recycling satellites snip off the solar panels, bring them to a central depot, again with the space tugs fueled by debris, and then bring them to other satellites where either these panels they were designed with are damaged or have been designed without solar panels to save on launch costs in the first place. That's getting a bit far out, but yeah, the capability there. Okay, so you see 1 or 2 questions in the chat?
No, I've just been writing back and forth with Mario. He came in late, so I'm going to send him everything. Was there anything specific that you wanted to address with Adrian or with Mario?
Sorry about that. Double muted. Can you hear me okay?
Yeah.
Yep.
All right. I'm interested in potentially developing some SATCOM payloads. And so this is an attractive option due to accommodating for smaller sizes and potentially lower costs. So this is it's not something urgent that I'm going to be doing anytime soon, but it's something I'm looking like down the pipeline a bit. So I would just love to learn a little bit more about the capabilities, limitations, etc. And I apologize for dialing in late. Some of this may have been answered earlier, but I made it as soon as I could. Sorry, over.
That's perfectly all right. Follow up with me. My email is in the slide deck. One point I didn't get back to, if we can go back up 2 slides, please.
Yep, give me just 1 second here.
Related to Mara's question.
That one?
Yeah. So part of my thinking for the commercial operations is a retail model where you got a whole bunch of customers and okay, fine. If we only get like the basic stuff, the demand is already there. CubeCab can still stay in operation. One of the ways we would really profit is if we can get what's called mega constellations, 1,000+ satellites. Obviously, it would take us a while to launch them all, but if we do get any large constellation customers, like say for comms, now granted these have to be individual CubeSats, and some constellations just we don't do CubeSats, but those who do, we can launch a satellite directly to its intended orbit, and if any elements of the constellation go down, we can launch replacements right to that orbit. Make the individual satellites quite a bit more capable than if, okay, the whole bunch is launched here, and then they have to filter out, which means they have to spend quite a bit of their mass on Delta V to filter out. So, yeah, we have a little extra capability there if this comes out. Okay.
I got one more question for you, then we got to wrap it up, I think. What about in the polar regions? So I did a lot of work when I was at the Naval Research Laboratory with the Canadians, and I was above the Arctic Circle, and literally we had to do 5 SATCOM hops to get far enough south to have a 1 degree above the horizon link to a satellite. Why are satellites not put into polar orbits? Does it have to do with the fact that population is less dense? Does it have to do with the problems within the ionosphere, or
pretty much the first one? Polar orbit means that it's not as available over the rest of the Earth, and since there's not that many customers at the poles, then there's just not that much incentive to launch something up there as opposed to concentrating service on the rest of the Earth. But
your solution would make it affordable to put something.
Oh, absolutely. We could launch a specific. In fact, if you would go to slide 12, so that's 1, 2, 3, 4, 5, 5 more slides, I think. 2 more. Yeah. So this touches on some of the benefits of rapid responsive launch. I forget if I specifically put it in here, but another capability that's been presented is if you got a mission to a specific point on the Earth, and your enemy already knows what satellites are going over and is prepared for that, you could say launch a few hours before your mission, and the enemy would have a few hours to prepare if they even have that degree of command and control warning for, okay, the satellites are coming over this way now with this timing. And usually most of the places we would go, with the opposition just doesn't have the ability to deal with that if they do have the ability to jam other satellites.
Okay.
Okay. And before we wrap up, I would like to just quickly touch on a few of the other backup slides. So backup 1. So this is the main difference between the Cab 3A and Cab 3B. Again, F-104 versus F-15 and others. 3A is primarily intended for civilian use. Cab 3B is primarily intended for military use. There can be some crossover between them. Certainly, there's no objection to launching stuff on the Cab 3A for military use, especially if it's a non-emergency. Why not? Okay, forward 2. So we call out Ukraine as a specific case. In fact, we were one of the competitors for SpaceX back in the year before Russia's invasion. We were literally presenting to Ukraine's legislator. Here is a proposal that wound up to be much like what Starlink was, but white labeled specifically for Ukraine and under Ukraine's controls. Unfortunately, our proposal got mired in bureaucracy, and then they got back. We said we could accelerate stuff to a 12-month development cycle to start getting stuff up. They took 6 months and then said, "Can you do it in 6 months?" 12 months was already accelerating. We couldn't do it in 6. We could do it in 12. And then they debated for 6 months, and then they got invaded, and they didn't have the money to. Surprise! They didn't have money for space development when they're being invaded. But yeah, we did quite a bit of analysis on stuff we could have done specifically with 3U CubeSats and stuff that is now being done with 3U CubeSats. There are some people who say, "Oh, the DoD does not ever use CubeSats." Has never. Yes, it has. Yes, it does. Okay, next slide. So this is another mission, basically a rapid iteration. I said we can launch quickly. That's not just for emergency use. You could say launch Monday, test out Tuesday and Wednesday, then deorbit the satellite, build a new design and build a new satellite Thursday and Friday. We actually specifically talked to SolidWorks, and they will do design and manufacture that fast with their latest version. And then ship the satellite to the launch facility over the weekend. Test a new iteration of hardware every single week until you have qualified it in space. Rapid iteration. Okay, next slide.
Okay, you got 2 minutes.
Okay, very short version is it is actually policy to do this kind of thing as opposed to the big juicy targets. Done.
All right, thank you. Real quick, does anybody have a quick question? Let me know. Otherwise, reach out after. Okay, so Mario.
Okay, there have not been any CubeCab launches, period, because we haven't managed gotten the funding to get from where we are. We're currently TRL 4. We need to get the pieces, including funding. We haven't done an SBR, so we could do, say, an SBR phase 3 as a contracting vehicle.
So, Adrian, did I put you in touch with Goodman?
I do not recall that name already,
Okay.
but
yeah. So he presented on the forum, but yeah, I'll get you in touch with Goodman Technologies. I'll make a note of that.
Yeah. Certainly,
anyone else?
Personally, we could possibly do that, but we need to get the rocket funded for development before we can actually do all these orbital launches. There are so many missions, but we're having to cross the Valley of Death to get all of this. What's ICD? I know multiple things you could mean. Which one do you mean?
Interface control.
Not yet. Asterisk. See the CubeSat specification on CubeSat.org. We're using that as our ICD for now, but there's nothing specific to CubeCab yet. But yeah, CubeSat.org, public domain. The CubeSat specification is out there. We are building our launch vehicle around it.
Okay, thanks. Great conversation. Fantastic interaction with the community. Really appreciate that. Anybody, if you have anything else, you can always reach out. The videos will be up. If you want the video through they won't go up till next week, but if you want the video ahead of time, you can either get it off of the document repository through the website, or just shoot me an email and I can put it on a shared G drive, or send it to anyone in the federal government through a DoD safe link. Anything to close, Adrian?
I believe we've got all the points, and you said we're out of time, so.
Sounds good. So I want to thank everybody. We hope to have Adrian back to discuss another topic as soon as he's ready for that. But great session again. No forum next week in honor of Juneteenth holiday. Next session is June 26th, and I will see hopefully everybody there.